Okay, we're going to continue with our trig functions and right triangles and look at some applications of trig functions. So remember, we've looked at sine, cosine, tangent, cosecant, secant, and cotangent. When we plug this in for any of the six, let's just look at sine. You're going to do sine of an angle, and the answer is a ratio, okay? That's important to remember when you set up all of these, sine, cosine, tangent, whatever. You plug an angle in, you get a ratio out, and the ratio being the sides, opposite over hypotenuse, adjacent over hypotenuse, whatever it might be, okay? So, little vocabulary. Solving a right triangle. How do you solve a triangle? Solving a triangle means find all of the missing side lengths and angle measures. So anything that's not given to us, we need to find, okay? So if I want to find a missing ratio, we can use the angle to do that. If I want to find a missing angle, we can use the ratio to do that, okay? So on number one, this process is a little bit long. It has a lot of parts because we're solving for multiple things. So what do we need to find in this triangle? Angle B was not given. The other two are 34.5, and then angle C is 90. That's our right angle. And then side A and side C were not given to us. First thing is that we want to try to use as few rounded measures as possible. So we always want to use the numbers that we were given whenever we can. Sometimes you might have to use the other ones, but okay. Let's start with the missing angle because that's going to be the easiest. What do we know about all three angles in a triangle? They have to add up to 180 degrees. So we know that 34.5 degrees plus 90 degrees plus whatever B is has to equal 180 degrees. So we can subtract all of that from 180 and we get 55.5. And again, we're measuring in degrees. We're measuring 55.5 for angle B. So we've already got one done. This angle here, 55.5 degrees. Now we just need to find the sides. And to do that, we're going to use our trig ratios that we've done before. So let's start with A. So to find angle A, or side A, side A is the opposite of the 34.5 degree angle. And then B is the side I was given, so I always want to use that. That's the adjacent. So opposite and adjacent, remember SOHCAHTOA, that's going to be tangent. So the first thing we can do is say the tangent of 34.5 degrees is going to be equal to opposite, which is A, over adjacent, which is 10.5. If we cross multiply, we get this over 1. 1A is equal to 10.5 tangent 34.5 degrees. Double check that your calculator is in degree mode, and then go ahead and type that in. 10.5 tangent 34.5 degrees is 7.2. It didn't tell us how to round. Let's do the tenth for sides. 7.2. That is side A. Now, if we know two of the sides, we can use the Pythagorean theorem, but we just rounded this number. So I'd rather not use a rounded number to try to find my answer. I know that C is the hypotenuse, and so if I put together hypotenuse and adjacent, cosine is equal to adjacent over hypotenuse. So that's what I'm going to use this time. This time, I know the cosine of 34.5 degrees is equal to, remember, ca for cosine, adjacent, which is 10.5, over hypotenuse, which is C. If we cross multiply this time, we get 10.5 equals C times the cosine of 34.5 degrees, and then we need to divide both sides by cosine of 34.5 degrees. That's how we're going to solve for C. Go ahead and put that in your calculator. 10.5 divided by cosine 34.5, and we get that C is equal to 12.7. And so there it is. We found all three of the missing sides. You're going to have to use all different ratios. It just depends on what you were given to start with to be able to figure out what is missing. Okay, let's look at number 2. This one doesn't have any labels, and it's also tipped over kind of funny. So if you need to redraw it so that it looks a little bit better, we can do that. I would start by labeling your triangle so that we can talk about the sides. So I'm going to name mine like this. I always like to make the right angle C. That makes then this side C, this side B, and this side A. We know some of those. And again, like I said, if you don't like looking at it sideways like that, you can always redraw it however you want to so that it makes more sense. So if this is 59 degrees, that makes this B, this C, and this A. So C is equal to X, and A is equal to 34, and B we don't know. So in this one, we need to find X or the C. Whoops, I keep clicking on a pen. X or the C, we need to find B, and we need to find angle A. This is just like number 1. So pause the video, please, and take a moment to work through that and come back here to check your answers in just a few seconds. Okay, this is what I got for each of these. Now, for the cosine one, what I want you to notice, maybe you noticed this on the previous one, what always ends up happening on these when you solve for X, the ones where X is in the denominator, these two end up switching spots. So that's why it becomes 34 over cosine of 59. You can remember that if you want to save yourself a step. Okay. So now let's look at a couple that are application problems in more of a context. So from a point on level ground 125 feet from the base of a tower, the angle of elevation is 57.2 degrees. Approximate the height of the tower to the nearest foot. Well, we've already seen this. So everything's already labeled for us. Again, think about the sides that we have. A is the opposite, 125 is the adjacent. Pause the video, see if you can decide which trig function you're going to use, set it up, and solve for A. So we should pick tangent because it's opposite over adjacent. So the tangent of 57.2 degrees is equal to opposite, which is A, over adjacent, which is 125. So A is going to be 125 times tangent of 57.2 degrees. 125 tangent 57.2. 193.96, so that's going to round up to 194, which is what they wanted anyways, to the nearest foot. Easy. When we round to the whole number, that's nice. Okay. Number 4, from a point on level ground 80 feet from the base of the Eiffel Tower, the angle of elevation is 84.5 degrees. Approximate the height of the Eiffel Tower, and this is pretty accurate, to the nearest foot. Now this one is tricky because they did not give us a picture. So we need to think about what that picture would look like. So we have the Eiffel Tower, whatever the Eiffel Tower looks like, something like that, not really. We have the Eiffel Tower, and so we have the height of the Eiffel Tower. And we are measuring from there. I'm going to draw this in like a regular triangle over the top. So we have the height of the Eiffel Tower right here. From there, we are measuring from a point 80 feet away. This is not to scale. And so the angle of elevation would be this right here. And that, they said, is 85.4 degrees. We want to solve for the height of the Eiffel Tower. Pause the video and try that yourself. Okay, again, this one said to the nearest foot, so the answer is 994 feet. We looked that up one year, and that's pretty darn close to what the actual height is, okay? Now, number 5 is a little bit different because here we're trying to find a missing angle. So, number 5 says a kite flies at a height of 30 feet when 65 feet of string is let out. If the string is in a straight line, find the angle that it makes with the ground. So here's what we've got. We are standing, let's say right here. Right here. And our kite is somewhere over here, okay? So the kite has a vertical drop straight down to the ground. That's going to be perpendicular to the ground. The ground, we don't know what it is, but they told us the height was 30 feet. And that's when 65 feet of string is let out. We want to find the angle that the string makes with the ground. Now this is different. We haven't solved for an angle before. So this time we need to figure out what the ratio is that we have. If we look at our angle theta, we have the opposite side and we have the hypotenuse. SOHCAHTOA. That's going to have to be sine. That's one with O and H. So the relationship I know is that the sine of theta is equal to opposite 30 over 65 hypotenuse. So this time we have the whole ratio and we're trying to find the missing angle. The way we do this to find theta is we take the sine inverse of the ratio. Sine inverse, remember, inverse is undo. So if I want to undo the sine, I need to do the sine inverse to undo it. Now, sine inverse is going to be the same button as sine, but you have to push second. So you say second sine, and that should put the little sine -1. That means sine inverse of 30 divided by 65 equals, we get that theta is equal to 27 to the nearest tenth of a degree, 27.5 degrees. We found the angle here this time, okay? So that's how you can use the inverse feature there. Now this last one is tricky because it uses 2 triangles, okay? So this is the last one. Number 6 says, this is weirdly descriptive, this problem, but it's kind of silly. You are taking your first hot air balloon ride. Your friend is standing on level ground 100 feet away from you from your point of launch, making a video of the terrified look on your rapidly ascending face. How rapidly? At one instant, the angle of elevation from the video camera to your face is 31.7 degrees. 1 minute later, the angle of elevation is 76.2 degrees. How far did you travel to the nearest tenth of a foot during that minute? First thing that's tricky is we have to try to draw this picture. So you're in the balloon, your friend is on the ground. So here's your friend on the ground, and they are standing 100 feet from where the balloon started going up into the air. So the balloon is going up, 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 up. However that happens, here's the balloon. Okay, so we're up there in the balloon. So we have 2 different things happening. At one instant, the angle of elevation from the video camera to your face was 31.7 degrees. So at some point, we're looking at this triangle. At some point, the balloon was right here. Okay, so that was when this angle was 31.7 degrees. But then the balloon keeps on going, and then the next time they look at your face, the angle, which is not just this little sliver, it's again all the way to the ground, is 76.2 degrees. We want to know how far did we travel between those 2 points, so we're looking for this height right here. We need to use, the only right angle is right here, so we need to use both triangles. We have first this short triangle, and then we have this larger triangle. Those are the two things that we're going to be using to figure this out. So both of these are going to be tangent. We're going to look at, let's call this A, and then let's call this whole height B. So we've got opposite and adjacent in both of these cases. So the first one we need to find is A. Let's start with the small triangle. So we have tangent of 31.7 degrees equals A over 100. To figure out B, we're going to say tangent of 76.2 degrees is equal to B over 100. That 100 is not changing. How are we going to find the distance between the two? We're going to find A and B, and then we're going to subtract them. The tall one minus the short one, that'll tell us the distance in between. Pause your video and see if you can finish this the rest of the way. Okay, these are the values I got individually for A and B, but then remember what we want is this distance right here. So we need to subtract the tall one minus the short one, and we get 345.3 feet. They did ask us to round to the nearest tenth of a foot, which is 1 decimal. So that's it. It's just more practice with your SOHCAHTOA stuff today, and I will see you when I see you.